In this lecture, we solve the problems based on the de Moivre's theorem. So the first example which we are taking over here is if alpha is equal to 1 plus I, beta is equal to 1 minus I, and cot of phi is equal to x plus 1, prove that x plus alpha to the power n minus x plus beta to the power n upon alpha minus beta, which is equal to sine of n phi into cosec to the power n phi. Now let us try to solve this question. We have given that alpha is equal to 1 plus I, beta is equal to 1 minus I, and cot phi is equal to x plus 1. Then we have to prove that x plus alpha to the power n minus x plus beta to the power n upon alpha minus beta, which is equal to sine n phi into cosec to the power n phi. So if you want to prove this result, so let us take the left hand side. So before taking the left hand side, let us try to calculate the value of x plus alpha, value of x plus beta, and the value of alpha minus beta. And after calculating these values, if we substitute over here in the left hand side, definitely we get the right hand side. So let us consider what is x plus alpha. So x plus alpha, x is equal to x. What is the value of alpha? Alpha is nothing but 1 plus I. So let us put alpha is equal to 1 plus I. Now, but what is the value of cot phi? Cot phi is equal to x plus 1. So x plus 1 can be written as cot phi plus I. And again, we know that what is cot phi? Cot phi is nothing but cos phi upon sin phi plus I. So if we take the LCM, this is divided by 1. So LCM is sin phi. So this is cos phi plus I sin phi upon sin phi. Therefore, x plus alpha to the power n, which is equal to cos phi plus I sin phi upon sin phi. And if we apply the de Moivre's theorem, this n is multiplied to with phi and here also with phi, and this will become sine to the power n phi. So it is cos n phi plus I sin n phi whole divided by sine to the power n phi. So this is the value of x plus alpha to the power n, this value. Let us try to find out what is the value of x plus beta to the power n. So x plus beta is equal to x plus 1 minus I, but again x plus 1 is equal to cot phi minus I. Again, if we write down cot phi is equal to cos phi upon sin phi minus I, and if we take the LCM, LCM is sin phi, so cos phi minus I sin phi upon sin phi. And now, therefore, x plus beta to the power n is equal to cos phi minus I sin phi upon sin phi whole to the power n. Now we again apply the de Moivre's theorem over here, and it will be reduced into cos n phi minus I sin n phi divided by sin to the power n phi. Now let us calculate the last part, alpha minus beta. So alpha is equal to 1 plus I, beta is equal to 1 minus I. So 1 plus I minus in bracket 1 minus I, which is equal to this plus 1 and this minus 1 will cancel, this minus plus I and this minus and minus will plus I, which gives us I plus I is equal to 2I. So let us consider the left hand side. Left hand side is equal to x plus alpha to the power n minus x plus beta to the power n upon alpha minus beta. So x plus alpha to the power n is cos n phi plus I sin n phi whole divided by sin to the power n phi. So we have taken this in the denominator, minus x plus beta to the power n is in bracket cos n phi minus I sine n phi whole divided by alpha minus beta is equal to 2i, and this sine to the power n phi comes to the denominator. So now this cos phi is positive, this cos phi is negative, and then I sine n phi, and this minus and minus will become plus. So plus I sine n phi gives us 2i sine n phi upon sine to the power n phi. So this 2i will cancel, and we have sine n phi, and this goes to numerator will become cosec to the power n phi. So this is the right hand side. So this is our result. Thank you.